Today we start our unit on exponential functions, okay? Before we can get to transformations, which is really what our goal is today, right? Before we can get to transformations of exponential functions, I need to make sure you understand what an exponential function is. Can you give me an example of an exponential function? So you think x squared is an exponential function? Logically, people think that that's an exponential function because it has an exponent. But just because something has an exponent, does that make it exponential? No, what kind of function is this? That's a quadratic for sure. Well, what some people earlier said, well, if the number is bigger than 2. So is that an exponential function? No, that's a cube. Oh, then it must be a 4. Oh no, that's just a quartic? Okay, so what's an exponential function? Is it with an x in the denominator? No, that's rational. That's what we just did, right? That's what we just finished. Is it like this? No, that's a radical. We already did those, right? So what does it look like to be an exponential function? This is a quadratic because the x is squared. This is a cubic because the x is raised to the third power. This is a rational because the x is in the denominator. This is a square root function because the x is in the square root. So what is an exponential function? Absolutely. Maybe like this? Absolutely. Okay. So just so that we're all nice and mathematically tidy, right? F of x equals 2 to the x power, okay? Now, exponential functions are slightly different than all these other ones that we've already talked about, because if I said, give me the parent function of a quadratic, you know exactly what to draw, don't you? You go to the origin, you go zhunk, zhunk, you can go over 1 up 1, over 2 up 4, over 3 up 9, right? And then you draw it, right? And it's symmetric, so you can draw the other side too. So there's one parent function, right? What makes something a parent function? If nothing is being added or subtracted, divided or multiplied to it, right? So is this a parent function? Yes. Is this a parent function? Is this a parent function? What about this? Is that a parent function? 7.9 to the x power? So all of these are parent functions? Yeah. How many are there then? An infinite amount, right? There's a lot, yes, but there's an infinite amount because I can make anything the base of this exponent, can't I? Well, we didn't even talk about this. What if it's like this? Oh my gosh. We don't even have all these numbers like this. We have these numbers like this, right? 1/3 to the x. It could be 1 over 24 to the x if we wanted it to be, right? 3 over, how about if we say 16? Because then that won't simplify, right? 3 over 15 would just be 1/5. But yeah, all of these are also exponential functions, which is where the whole infinite thing comes from, right? Now, I made 2 columns on purpose, and I divided the numbers into different like things in each column. Can you tell me the difference in the columns? One is fractions and one is decimals. Okay, I mean, I'll go with that. It's not exactly what I was looking for, but it's not wrong. Well, look at these numbers compared to these numbers. All of these numbers are, do you mind if I call them b? Because it's the base of the exponent. Okay with that? All of these numbers are greater than what? 1. All of these numbers are what? Less than 1 and greater than 0, exactly. Okay? So do you see now why I put them in 2 different columns? Do you see why I argued about the fraction thing, right? Because 5/4 isn't 5/4 a fraction? But what column would that go in? That would definitely go in the first one, wouldn't it? Okay. So here's the difference though. There's actually two separate types of exponential functions, and it depends on what the base is. If the base is greater than 1, that's actually called exponential growth. And the base is between 0 and 1, that's called exponential, do you know? Decay. Now, I need you to know what these graphs look like. Okay, I need you to know what they look like. No, we can just draw them. We're fine. We're not going for specifics right now, more generalities, if that's all right with you. We'll get to specifics eventually in a minute. Okay? But the parent function for exponential growth, oh no, please ignore that part. I totally messed up. Can you forgive me? Okay, it actually starts on here. Oh, geez Louise. And does that. Because it from left to right, what's it doing? It's growing. So it starts here and goes up. Now, this point right here is a very specific point. If x is 0 in any of these equations right here, if x is 0, what is y? Because anything to the 0 power is what? 1, right? Anything to the 0 power is 1. So that point right there is 0, 1. Okay? Now, some of you are going, oh, okay, no, wait, I remember that. Wait, do you really, or are you just saying that to make me feel better? Because you know it does not make me feel better. You know, I want you to be honest and tell me whether you remember it or not. Is that fair? We talked about it when we did our exponent rules. Anytime anything to the 0 power is 1. Do you remember now? We wrote it on the back of our exponent foldable. You mean to find it real quick? Oh, you got it, you remember? I think mine's right here. Yeah, mine's right here. Here's our exponent foldable, and we put it right back here. Anything to the 0 power is 1. On the very back page. Very back page. Yep, right there. Anything to the 0 power is 1. Okay? It's okay. We don't have to remember everything exactly the minute we're asked for it, right? That's why we make foldables, so we can look stuff up. Okay? So this is what exponential growth looks like, right? So what do you think exponential decay looks like? So from left to right, what's it doing? From left to right, like it's dying, right? Decaying. We don't want to say dying in school, though. That's sad. Okay. But it starts here and just goes like that, right? But guess what this point right here still is? It's still 0, 1, isn't it? Because from left to right, it's decaying, but anything to the 0 power is 1, just like in this column, just like it was in that column. Okay? Any questions about that? Okay. While we're here, what is the domain of this function? How far to the left does it go and how far to the right does it go? So all real numbers or negative infinity to positive infinity, right? What about the range? How far down does it go? Does it cross the x-axis? What is the x-axis in this problem? Your favorite math word and mine. It's an asymptote, isn't it? Okay. It gets closer and closer to that x-axis, but it doesn't ever cross it. So it's everything y is greater than 0. So it looks like 0 not including 0 and then to infinity. So does this one have the same domain and range, or is this one's domain and range different? How far left and right does it go? All real, so negative infinity to positive infinity. And then how far down does it go? Is there an asymptote here again? Yes. So y is greater than 0 or 0 to infinity. Okay? Oops. There. That's much better. So now, here's the deal. A lot of this stuff we talked about on the first or second day of school. So do you see why I went over it with you again? Because it's been a couple sleeps since the first and second day of school. Yes? Are you feeling comfortable with knowing exponential growth and decay? Knowing what the graphs look like? Knowing about B, the B value and things? Okay. Then now let's talk about transformations. This is where we're going to start. Y equals 2 to the x power. Okay? Okay, so this is the part where you're going to start teaching the lesson. I'm just going to write and then just agree with you when you get the right answer. Is that fair? Yeah? Okay, so who's going first? Okay, come on. Come on, come on. You're fine. So this is the parent function, right? Right? So talk about this transformation for me. When I add k at the end, what kind of transformation does that cause? First of all, is this k inside of the function or outside of the function? It is outside. Okay, we'll make sure you understand the difference in a minute. But yes, for now, this is an outside number. So does outside cause a vertical change or a horizontal change? It's a vertical change. So k is going to cause a vertical change. Now, what kind of a change does it cause? How do you know it's a shift? Or perfect. Anytime a number is being added or subtracted, that causes a vertical shift. And what's the most important part of this word? The F, right? The F, because if we leave off the F, it's a different word. So we've got to have our F in this word, right? Okay. Now, a vertical shift moves which direction? Up or down. So we're going to actually just draw some arrows to remind ourselves it's an up or down movement, right? That's vertical. Okay. So here's an example. Y equals 2 to the x plus 5. How is that going to move compared to the parent? Perfect. Up 5. You're remembering this? Good. Give me 5. Perfect. Have a seat. Okay, who's next? Come on. Okay, what color you want to use? Green. Okay. What about this? Do you remember that? Do you remember us talking about things like that? First of all, tell me if this is inside the function or outside of the function. It is. And how do you know it's inside? It's with the x, right? The non-correct math vocabulary is it's little baby and up high, right? It's inside the exponent. That's not correct math vocabulary. We don't ever want to talk about being high for math vocabulary. That's a bad idea, okay? But this is inside. If it's inside, what kind of a change does it cause? A horizontal change. So H is going to cause a horizontal change. Now, what kind of horizontal change is A going to cause? How do you know it's a shift? Well, if it's being or adding, right? If it's adding or subtracting, that's a shift. Shift. Now, you already answered my next question. My next question was, which way does it go if it's a horizontal shift? And you said left or right. So we're going to draw our arrows here to remind ourselves that's a left or right movement. Okay. And then here's an example. Y equals 2 raised to the x plus 5. Now, where's that going to go? How do you know it's going to go left 5? It says plus 5. So if it's inside, it's backwards of what we think, isn't it? So this is going to move left 5. Perfect. For the people watching the videos, I'm giving them high fives. I'm not hitting them. Okay, just making sure. Okay. Who's next? Come on. Choose a color. Okay. So we're talking about A now, right? So is A inside or outside? Outside, right? It's outside because it's out, it's not inside the exponent, right? So it's outside. If it's outside, what kind of change does it cause? It is a vertical change. Anytime it's outside, that causes a vertical change, right? But what is A doing to this function? It is multiplying, right? Is it a shift then? Right, because shifts are only if we are adding and subtracting, right? So this is going to be a stretch. You said stretch, but what else might it cause? A stretch or a shrink. How do we tell the difference between a stretch or a shrink? It depends on what the number is, right? So let's remind ourselves how to tell if it's a stretch or a shrink. We have to look at A and see what it is. If A is greater than 1, if it's positive, it's a stretch. But it also has to be greater than 1, okay? Because 1/2 is greater than 1. Excuse me, 1/2 is positive, but that's not a stretch, is it? Okay? So if A is greater than 1, it's a stretch. How do we know if it's a shrink? Less than 1 or greater than? Greater than 0. You knew it had something to do with 0, right? Okay. Now, does this look familiar to you at all? Maybe from something I wrote earlier today? That's how I told the difference between growth or decay, right? Is that exactly the same thing? It is not, is it? Okay. Looking at the base to tell if it's growth or decay doesn't make a difference whether we know a stretch or shrink. It happens to be the same parameters, greater than 1, between 0 and 1, greater than 1, between 0 and 1. So it's something familiar to you, but it doesn't really work the same way. Does that make sense? Okay, so what if it looked like this? Y equals 5 times 2 to the x. Is that a stretch or a shrink? Why do you think it's a stretch? It's greater than 1. Does that make sense? What if it looked like this? Y equals 1/2 times 2 to the x. It's a shrink because why? So can we say between 0 and 1? Is that okay? So A is between 0 and 1, so we know that that is a shrink. Okay? Now, I need to give you some very specific kind. I mean this as kind as I can. Okay? Don't, 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 don't. That's one don't for every single one of you. Don't multiply these together right now. In order of operations, exponents come before multiplication. I can't say this is 10 to the x. If I do, I've changed the whole problem. Okay? We have to be patient with ourselves and know that transformation-wise, this causes a stretch, and this right here is the parent. Does that make sense? High five. Perfect. All right, one more. We got one more. Who's doing it? Good girl. Come on. Oh, I guess I could choose one more color. Okay, choose a color. Your choice. Purple. Okay. I'm not going to write anything up here. We're just going to talk about it down here. Oh, pink, you want to change your mind? That's fine. No, no, no. That's fine. Okay. Again, I'm not going to write anything up here on it. We're just going to talk about it down here. Okay. We talked about if A is greater than 1, and we talked about if A is between 0 and 1, but what if we not talked about A being negative, right? What if A is negative? We didn't talk about it up here because it doesn't change whether it's a stretch or shrink. But what if it's negative? What does that cause? Perfect. Wait, can I take back my perfect for a second? A reflection over what? Okay, I'm going to give you back the perfect now. Okay, reflection over the x-axis. Okay, so what happens if it looks like this? Y equals -2 to the x. Is that a reflection? Yes, because what's our A value? Negative 1, right? Our A value is negative 1. That's our B value. That's our base, right? The number in front of it, though, is our A value. So what about if it looks like this? Is that also a reflection? Yes. What else is it? A stretch, right? Does that make sense? We can have two parts at the same time. You know that. We've talked about that before, right? Give me 5. Perfect. Okay. Do you have any questions about transformations of exponential functions? Once we got through all of it, was any of it a surprise? What was any of it something you haven't seen before? No, you've definitely seen all of it before, right? I think we've done it 5 times now with this 4 other parent functions. Now this was our 5th, right? We still have a couple more times to do it, so hopefully we're starting to get the hang of it. Yes? Any questions at all? I mean, about exponential functions. Okay? Peace.